At 6:18 a.m. on April 18, 1943, Technical Sergeant Frank Holloway crouched beneath the left engine nacelle of a P-38 Lightning at Fighter Strip Number 1 on Guadalcanal, watching Captain Thomas Lanphier climb into the cockpit of an airplane Holloway had spent the entire night illegally modifying. Holloway's hands still smelled like engine oil and magneto grease. His eyes burned from no sleep. Around him, 17 other P-38s were starting their engines for what intelligence called the most important mission of the Pacific War. Holloway had committed what could be court-martial offense on every single one of those aircraft. The mission was simple: intercept and kill Admiral Isoroku Yamamoto, the architect of Pearl Harbor, the most important military target in the entire Japanese command structure. Intelligence had his exact flight plan. The P-38 was the only American fighter with the range to reach him. But the P-38 had one fatal problem that had caused 14 mission failures in the past 8 weeks. A problem that killed every attempt to intercept high-value targets. A problem Holloway had been ordered not to fix. He'd fixed it anyway. And in about 4 hours, the world would find out if his unauthorized modification worked, or if he'd just sabotaged the most critical mission of the war. Frank Holloway was 26 years old. He grew up in southwest Detroit, 3 blocks from the Ford River Rouge plant, where his father assembled V8 engines for 22 years. Holloway knew engines before he knew how to read. By age 14, he was timing ignition systems for his father's supervisor. By 18, he was the youngest engine balancer Ford had ever employed. When he enlisted in April 1942, the Army Air Forces looked at his file for exactly 6 seconds before assigning him to P-38 maintenance. He'd been on Guadalcanal for 11 months. He'd maintained engines through tropical humidity, volcanic dust, and fuel contaminated with sediment from hastily constructed storage tanks. He could rebuild an Allison V1710 in darkness using only touch and memory, but there was one thing he couldn't fix. Not because he didn't know how. Because he'd been explicitly ordered not to. The P-38 Lightning was, on paper, the perfect interceptor. 2 Allison engines generating 1,475 horsepower each. Top speed of 414 miles per hour, range of 1,300 miles. Fast enough to catch anything Japan flew. Strong enough to fight at any altitude, but every P-38 in the South Pacific had the same problem. During sustained high-power operation, the 2 engines would drift out of synchronization. The left engine would run at 2,950 RPM while the right ran at 3,020 RPM, or vice versa. It shifted constantly. That RPM difference created asymmetric thrust and vibration. The vibration caused drag. Drag reduced speed. At cruise power, it didn't matter much. But at combat power, trying to catch an enemy formation, that desynchronization cost 15 to 25 miles per hour. Which meant the P-38, the fastest fighter in the Pacific, couldn't catch anything when it mattered most. Lieutenant Robert Mitchell was 24 years old. He was from Eugene, Oregon. He'd flown 19 missions from Guadalcanal without a single confirmed kill. Not because he wasn't skilled. Because every time he got close to enemy aircraft, his P-38 couldn't sustain the speed needed to close the gap. On March 3, 1943, Mitchell was part of a 6-plane flight scrambled to intercept a Japanese reconnaissance aircraft spotted 80 miles northwest of Guadalcanal. The reconnaissance plane was a Mitsubishi Ki-46, one of the fastest aircraft Japan operated, but the P-38 was faster. On paper. Mitchell's flight climbed to 28,000 feet. They spotted the Ki-46 at 29,000. Mitchell pushed his throttles to full military power and started his intercept. For the first 2 minutes, he closed the distance. But as his engine sustained maximum RPM, they began drifting out of sync. First by 40 RPM, then 60, then 90. The vibration started. The nose wanted to yaw left. Mitchell corrected with rudder, but that added drag. His airspeed dropped from 390 miles per hour to 375, then 360. The Ki-46 maintained 350 and slowly pulled away. Mitchell chased for 14 minutes. He never got within firing range. The Japanese pilot saw him the entire time, knew Mitchell couldn't catch him, and continued his reconnaissance flight unmolested. Mitchell returned to Guadalcanal with full ammunition and the bitter knowledge that his airplane had failed him. He told Holloway about it that evening. Mitchell wasn't angry. He was exhausted. "I had him," Mitchell said. "I had the altitude, the position, the speed, and the airplane just..." Quick, Holloway knew exactly what had happened. He'd seen it in the maintenance data. Every P-38 lost speed during extended combat power. Every single one. 3 weeks later, Captain James Walsh led an 8-plane intercept mission targeting a Japanese bomber formation headed toward American shipping near Rennell Island. Walsh was 29 years old. He was from Houston, Texas. He had 2 confirmed kills and a reputation for aggressive tactics. Intelligence gave Walsh the bomber formation's exact heading, altitude, and speed. Walsh calculated the intercept perfectly. But when his flight reached combat power to close the final distance, the same thing happened. Engines drifted out of sync. Vibration increased. Speed dropped. The bombers completed their attack and turned for home. Walsh's flight pursued for 40 miles, but never closed within 1,000 yards. 3 American cargo ships were hit. 17 sailors died. Walsh didn't talk to anyone after that mission. He went directly to his tent. The next morning, he found Holloway at the maintenance line and asked a simple question. "Can you fix it?" Holloway said, "I know what's wrong," Walsh said. "Then fix it." Holloway said, "I'm not authorized." Walsh stared at him. Men are dying, Holloway knew. He knew better than anyone. The problem wasn't mechanical failure. It was design compromise. The Allison V1710 engine used magneto ignition. Each engine had 2 magnetos providing redundant spark to 12 cylinders. The magnetos were timed to fire at a specific crankshaft position, creating optimal combustion. When both engines ran at identical RPM with identical timing, the P-38 performed exactly as designed. But maintaining identical RPM required both throttles to be positioned with micron-level precision. And throttle cables stretched. Carburetors wore. Fuel mixture varied. Even with perfectly maintained engines, tiny differences in internal friction caused RPM drift during sustained high power. That 50 to 100 RPM difference between engines created asymmetric thrust. Asymmetric thrust required rudder correction. Rudder correction created drag. Drag reduced speed by 15 to 25 miles per hour. Holloway had known the solution since his second week on Guadalcanal. The magneto timing on both engines could be advanced approximately 3 degrees. Advanced timing produced more power per combustion cycle. More power per cycle meant engines could produce the same thrust at slightly lower RPM. Lower RPM reduced internal friction. Reduced friction made it easier for engines to naturally synchronize. It was a simple fix. 30 minutes per engine. No new parts required. Just rotating the magnetos 3 degrees and marking new timing references. But Allison Engine Company had certified the engines at factory timing specifications. The Army Air Forces had accepted those specifications. And the technical orders explicitly stated that magneto timing will not be adjusted beyond factory specifications without written authorization from Allison Engineering. Holloway had requested that authorization in writing on February 8, 1943. He'd submitted a detailed technical proposal explaining the synchronization problem and the timing solution. He'd included performance data from 11 separate missions showing speed loss during extended combat power. Allison Engineering responded 6 weeks later. Their letter stated that magneto timing was within acceptable tolerances and that field modification could void warranty protection and create liability issues should engine failure occur. The letter didn't mention that pilots were dying. It didn't mention that the P-38 was failing its primary mission. It mentioned warranties and liability. Holloway read that letter 3 times. Then he filed it and went back to watching P-38s return from missions they should have won. On March 28, 1943, Major Stephen Crawford led a 12-plane strike targeting a Japanese convoy reported 220 miles north of Guadalcanal. Crawford was 31 years old. He was from Sacramento, California. He'd flown 47 missions. He was careful, professional, and ruthlessly competent. Intelligence reported the convoy included a Japanese flag officer, possibly an admiral. This was a high-value target. Crawford's orders were clear: intercept and destroy. Crawford's flight found the convoy exactly where intelligence said it would be: 4 cargo ships, 2 destroyers, and 1 heavy cruiser. And flying top cover, 6 Mitsubishi A6M0 fighters. Crawford positioned his flight for a diving attack on the cruiser. But as they rolled in, the 6 Zeros dove to intercept. Crawford called for his flight to engage. That's when the speed problem hit. Crawford's P-38 was at full military power in a climbing turn, trying to reverse onto a Zero's tail. His engines started at synchronized 3,000 RPM. Within 40 seconds, they drifted to 2,980 and 3,060. The vibration made his gunsight shake. He needed right rudder to hold heading. His airspeed dropped from 385 to 360 miles per hour. The Zero he was chasing pulled away in a climbing left turn. Crawford's wingman, Lieutenant Peter Sullivan, called over the radio. "Lead, I can't stay with them. I'm at full throttle, but they're pulling away." Crawford responded, "Stay in the fight. We can outspeed them." But they couldn't. Not with engines vibrating out of sync. Not with asymmetric thrust bleeding airspeed. Not with a design flaw killing their primary advantage. The engagement lasted 9 minutes. Crawford's flight didn't shoot down a single Zero. They didn't damage the convoy. They expended ammunition and fuel and returned to Guadalcanal empty-handed while the Japanese convoy continued unmolested to its destination. Crawford filed his after-action report with precise professional language. He noted aircraft performance below expected parameters during sustained combat power operations. He noted inability to maintain speed during maneuvering engagement. He noted mechanical factors limiting tactical options. He didn't say his airplane had betrayed him. But Holloway read the report and knew exactly what had happened. In 6 weeks, between February 15th and March 31st, P-38 squadrons on Guadalcanal launched 14 intercept missions targeting high-value Japanese aircraft or convoys. 14 missions with perfect intelligence. 14 missions where they found the target exactly where they expected. 14 missions where the P-38's speed advantage should have been decisive. They achieved 0 successful intercepts, 0 kills, 0 mission objectives met. 37 P-38s flew those missions. All 37 pilots reported the same speed loss during extended combat power. All 37 reported engines drifting out of sync. Holloway documented every mission. He kept a private logbook with engine performance data, pilot comments, and his own calculations. The pattern was undeniable. The solution was obvious. But he had a letter from Allison Engineering telling him not to fix it, and men kept dying because he followed orders. On the evening of April 17, 1943, Holloway was rotating propellers on Lieutenant David Hayes's P-38 when Captain Thomas Lanphier walked up and said, "I need to talk to you." Lanphier was 25 years old. He was from Detroit, same as Holloway. He'd flown 37 missions. He was known for aggressive flying and absolute confidence. He was also known for ignoring rules that interfered with killing the enemy. Lanphier said, "We're launching a long-range intercept tomorrow, 400 miles. We're going to kill Yamamoto." Holloway stopped rotating the propeller. Lanphier continued, "Intelligence has his exact flight plan. Departure time, route, arrival time, everything. 2 bombers, 6 Zero escorts. He's flying right into our range." Holloway said, P-38's the only fighter that can reach him. Lanfear said, "That's right. Which is why I'm here." There was a long silence. Somewhere in the distance, a generator sputtered and died. Someone shouted for a mechanic. The jungle humidity pressed down like a wet blanket. Lanfear said, "I've read the mission reports. I know about the speed loss. I know the engines drift out of sync." Holloway said nothing. Lanfear said, "We're going to fly 400 miles at wave-top altitude to avoid their radar. Then we're going to climb to Intercept. We'll have maybe 3 minutes before the Zeros react. 3 minutes to get past 6 fighters and hit 2 bombers. If our speed drops, we fail. If our engines vibrate, we fail. If we can't sustain combat power, Yamamoto flies home and we miss the single best opportunity we're going to get in this entire war." Holloway met his eyes. "What are you asking me?" Lanfear said, "Can you make them faster?" Holloway could have said no. He could have mentioned the Allison letter. He could have explained warranty issues and authorization protocols. He could have protected himself. Instead, he said, "How many aircraft?" Lanfear said, 18. Holloway looked at the sky. The sun was setting. He had maybe 14 hours before takeoff. He said, "I can do it." Lanfear said, "It's not authorized, is it?" Holloway said, "No." Lanfear said, "If it fails, they'll court-martial you." Holloway said, "If it fails, you'll be dead." "Court-martial doesn't seem that bad." Lanfear almost smiled. Then he said, "Do it." At 2,200 hours on April 17, 1943, Holloway entered the maintenance tent alone. He'd sent the other mechanics to their quarters. He needed to do this himself. If the modification failed, if engines seized, if aircraft crashed, he wanted the blame to fall only on him. He'd spent 2 hours assembling tools and materials. Timing lights, magneto wrenches, marking paint, and 36 small metal tags he'd fabricated from aluminum sheet. Each tag had a tiny drilled hole and a reference line scribed with a file. The modification was simple in concept. He would rotate each magneto 3 degrees advanced from factory specification. Then he would install his custom timing tags so the advancement appeared to match factory marks. Any inspector would see what looked like correct timing. Only someone checking with precision instruments would detect the modification. The first aircraft was Lanfear's. Holloway started with the left engine. He removed the magneto access panel, disconnected the timing light, loosened the magneto mounting bolts. The magneto was spring-loaded, held in position by those bolts and a timing pin. He rotated it 3 degrees clockwise. Advanced, more power per combustion cycle. His hands were shaking. 3 degrees was precise. Too much advance would cause pre-detonation. The engine would destroy itself. Too little wouldn't solve the synchronization problem. He used the timing light to verify position. 3 degrees. Exactly. He installed his custom timing tag. Tightened the mounting bolts to exact torque specification. Then the right engine. Same process. Remove panel. Disconnect timing light. Loosen bolts. Rotate magneto. Verify. Install custom tag. Torque bolts. 12 minutes per engine. 24 minutes per aircraft. 18 aircraft. 7 hours of work. Holloway moved from aircraft to aircraft. His hands stopped shaking after the third modification. Muscle memory took over. Remove. Rotate. Verify. Install. Torque. Next. Around 0300 hours, he heard footsteps. He turned and saw Lanfear standing at the tent entrance. Lanfear didn't say anything. He just watched Holloway work for 2 minutes. Then he nodded and walked away. At 0610 hours, Holloway installed the final timing tag on the 18th aircraft. The eastern sky was turning gray. He could hear pilots gathering at the operations tent. He could hear engines being started for pre-flight checks. He gathered his tools. He hid the timing lights and special wrenches. He cleaned the marking paint from his hands. He walked outside. 18 P-38s were lined up on the runway. Their engines were running. The sound was perfect, synchronized, smooth, no vibration, No rough spots. If this failed, if the modification caused engine failure at 400 miles from base, 16 men would die. They'd crash into the ocean with no rescue possible. And it would be Holloway's fault. If it worked, they might kill the architect of Pearl Harbor. Holloway watched Lanphier climb into his cockpit. Lanphier looked down at him. Holloway gave him a thumbs up. Lanphier returned it. At 0618 hours, the first P-38 rolled down the runway and lifted into the dawn sky. 17 others followed. Holloway stood on the flight line and watched them disappear into the distance. He didn't move for 20 minutes. Then he went to the maintenance tent and waited. At 0618 hours, Captain Thomas Lanphier lifted off from Fighter Strip No. 1, leading a flight of 18 P-38 Lightnings. The mission was designated Operation Vengeance. The target was Admiral Isoroku Yamamoto. The distance was 435 miles each way. The modified engines ran perfectly. Lanphier leveled at 50 feet above the ocean. The formation spread into a loose line. They would fly the entire route at wave-top altitude to avoid Japanese radar detection. 435 miles at 50 feet. If anyone made a mistake, they'd hit the water at 280 miles per hour. Lanphier's engines were synchronized. Both tachometers read 2,200 RPM, exactly matched. No vibration. No yaw. The airplane flew straight and stable. He'd flown 37 missions in this airplane. It had never felt this smooth. At 0710 hours, they crossed the halfway point. Fuel state was good. Weather was clear. They'd seen no enemy aircraft. Navigation was perfect. At 0728 hours, still 200 miles from the intercept point, Lanphier began a gradual climb to 18,000 feet. The bomber formation would be at 20,000. He needed altitude and speed for the attack. He pushed his throttles forward to climb power. Both engines increased to 2,800 RPM, still synchronized. The tachometer needles moved together like they were linked. That had never happened before. Never. In 37 missions, his engines had always drifted during sustained high power. Every single time, not today. Lanphier keyed his radio. Sound off. Fuel state. Each pilot reported. All 18 aircraft had sufficient fuel. All 18 were in formation. All 18 engines were running perfectly. At 0934 hours, 435 miles from Guadalcanal, Lieutenant Doug Canning called, "Boogies, 11 o'clock high." Lanphier looked up. Two Mitsubishi G4M bombers, flying in loose formation at 20,000 feet. Exactly where intelligence said they'd be. Exactly on schedule. And above the bombers, 6 Mitsubishi A6M0 fighters. Lanphier's hands tightened on the controls. 435 miles, 14 hours of illegal modifications, 8 weeks of mission failures. This was the moment. He keyed the radio. Attack formation. Barber, you take the second bomber. I've got the lead. Lieutenant Rex Barber acknowledged. Lanphier broke left, climbing hard toward the bomber formation. His wingmen followed. Behind him, the remaining 16 P-38s engaged the Zeros to keep them off the bomber attackers. The Zeros saw them. They rolled and dove to intercept. Lanphier pushed his throttles to full military power. His engines jumped to 3,000 RPM. Both tachometers perfectly synchronized. No drift, no vibration. The P-38 accelerated like it had been launched from a catapult. The Zero pilots made their decision fast. 3 stayed high covering the bombers. 3 dove after Lanphier. Lanphier saw them coming. Normally, this is where the fight got complicated. Normally, he'd have to choose between speed and position. Normally, his engines would start drifting and he'd lose the advantage. Not today. He held full power in a climbing left turn. The P-38 responded instantly. No yaw, no vibration. The engines stayed locked at 3,000 RPM like they were mechanically synchronized. The lead Zero opened fire at 800 yards. Way too far. Desperate shooting. Lanfear pulled harder. The G-forces crushed him into his seat. His vision narrowed. But the airplane held the turn without any adverse yaw. He reversed right. The Zero tried to follow. The Zero was more maneuverable. The Zero could turn tighter. But the Zero couldn't accelerate in the turn. The P-38, with its perfectly synchronized engines, could. Lanfear came out of the reversal with 385 miles per hour. The Zero had maybe 310. Lanfear blew past him, extended 2,000 yards, and turned back toward the bombers. The lead bomber was maneuvering now. The pilot had seen the attack. He pushed his nose down, diving for speed and lower altitude where his escorts could cover him better. Lanfear followed. Full power dive. His airspeed went to 425 miles per hour. The bomber was doing maybe 280. He closed from 3,000 yards to 1,000 in 40 seconds. The bomber's rear gunner opened fire. Lanfear saw tracers arcing toward him. He didn't deviate. He didn't have to. The P-38 was closing too fast for the gunner to track. At 500 yards, Lanfear centered his gun sight on the bomber's right-wing root. He pressed the trigger. The P-38 carried one 20mm cannon and 4.50 caliber machine guns, all nose-mounted. All 5 weapons fired simultaneously. The combined rate of fire was 200 rounds per second. Lanfear's first burst missed low. He corrected. His second burst walked up the bomber's fuselage from tail to cockpit. He saw strikes. Metal pieces blew off the bomber's tail. The right engine began trailing smoke. He fired again. The 20mm rounds hit the wing root. 1, 2, 3 impacts. The bomber's right wing folded up and separated from the fuselage. The bomber rolled inverted and dove straight into the jungle below. Impact at 0936 hours. No parachutes. Lanfear rolled level. His heart was hammering. His hands were shaking. His engines were still perfectly synchronized at 3,000 RPM. He keyed the radio. Splash 1 bomber. Lieutenant Rex Barber had chased the second bomber down to 1,000 feet. The bomber pilot was running for the coastline, hoping to ditch near Japanese-controlled territory where he might be rescued. Barber's modified P-38 caught him in 2 minutes. Barber positioned behind him below. He climbed up into firing position. The bomber's top turret gunner fired continuously, but couldn't depress his guns low enough to hit Barber's approach angle. At 300 yards, Barber fired a 3-second burst. The rounds hit the bomber's left engine. The engine exploded. Fire spread across the wing. The bomber's pilot tried to maintain control. He was good. He kept the airplane level despite losing the left engine. He was trying to reach the beach. Barber fired again. This burst hit the cockpit. The bomber's nose pitched down. The aircraft hit the water at 200 miles per hour. It disintegrated on impact. Barber pulled up and looked around. The 6 Zero fighters had engaged the remaining 16 P-38s. It was a confused furball with aircraft scattered across 5 miles of sky. But Barber could see something the Zero pilots probably couldn't. The P-38s weren't losing speed during maneuvering. They weren't falling behind in climbs. When they needed power, the engines responded perfectly. For 8 weeks, the P-38 had been an aircraft that looked fast on paper but couldn't perform in combat. Today, it was performing exactly like it was designed to. 3 P-38s had cornered a Zero in a descending spiral. The Zero couldn't extend. Every time he tried to run, the P-38s caught him with superior speed. Finally, one of the P-38 pilots got a firing solution and the Zero came apart in midair. Another Zero tried to dive away from 2 P-38s. Normally that worked. The Zero could dive steeply, absorb the G-forces, and escape while the heavier P-38s had to level out. Not today. The 2 P-38s followed him through an 8,000-foot descent without losing ground. At 500 feet, one of them fired. The Zero hit the water. At 0943 hours, the remaining 4 Zeros broke contact and ran for home. Lanfear's formation regrouped. 2 bombers destroyed. 2 Zeros destroyed. 1 additional Zero probably destroyed. 0 P-38s lost. They turned southwest and headed back to Guadalcanal at 10,000 feet. Barber pulled alongside Lanfear's aircraft and looked across at him. Lanfear gave him a thumbs up. Barber returned it. The 435-mile flight home took 2 hours. Every P-38's engines ran perfectly the entire way. No drift. No vibration. No loss of synchronization. At 11:43 hours, Lanfear touched down on fighter strip number 1. 17 other P-38s followed. Holloway was standing at the flight line. He'd been there since 0900 hours. 4 hours standing in the sun, waiting, not knowing if his modification had worked or killed everyone. Lanfear shut down his engines. He climbed out of the cockpit. He walked directly to Holloway. Lanfear's hands were still shaking from adrenaline. His flight suit was soaked with sweat. He looked at Holloway for 3 seconds without saying anything. Then he said, "It worked." Holloway felt his knees go weak. Lanfear continued. "The airplane did everything I asked. Everything. No speed loss. No vibration. It flew like it was supposed to." Holloway said, "You got him?" Lanfear said, "Both bombers. 2 Zeros, and we're all back." Other pilots were gathering around. They were talking fast, gesturing, replaying the mission. Holloway heard fragments. "Engines perfect the whole time. Never felt the airplane respond like that. We had speed when we needed it." Lieutenant Barber walked up. He looked at Holloway and said, "What did you do to these airplanes?" Holloway said, "Routine maintenance." Barber said, "Bullshit. These engines ran like they've never run before." Holloway didn't respond. Lanfear said, "Can you do this to every P-38 on the island?" Holloway thought about Allison Engineering's letter. He thought about authorization protocols. He thought about court-martial risk. Then he thought about 14 failed Intercept missions. He thought about Lieutenant Mitchell chasing a reconnaissance aircraft he couldn't catch. He thought about Captain Walsh watching bombers escape while American sailors died. He said yes. Within 6 hours of the mission's return, every pilot on Guadalcanal knew something had changed. The official mission report mentioned successful intercept and target destroyed. It didn't mention unauthorized engine modifications. But pilots talk. And they'd all watched those 18 P-38s fly differently than any P-38 had flown before. On April 19th, Captain Michael Reynolds from the 70th Fighter Squadron found Holloway at the maintenance line. Reynolds was 28 years old. He was from Oklahoma. He'd flown 32 missions with 1 confirmed kill. Reynolds said, "I watched Lanfear's flight from 15,000 feet during the intercept. Those airplanes were holding speed through maneuvers." "My airplane doesn't do that," Holloway said. "Different pilots, different techniques." Reynolds said, "Don't give me that. What's different about those aircraft?" Holloway looked at him. Reynolds looked back. Holloway said, "If I tell you, I'm admitting to unauthorized modifications. If I'm admitting to that, I need to know you won't report it." Reynolds said, "You think I'm going to report something that might keep me alive?" Holloway explained the timing modification. Reynolds listened carefully. Then Reynolds said, "Do it to my aircraft." Holloway said, "I'll need authorization from your squadron commander." Reynolds said, "Then I'll get it." 2 hours later, Major Carl Spencer, commander of the 70th Fighter Squadron, arrived at the maintenance tent. Spencer was 33 years old. He'd flown 51 missions. He'd lost 8 pilots in the past 6 weeks. Spencer said, "Reynolds says you've modified the engine timing on Lanfear's aircraft." Holloway said, "Yes, sir." Spencer said, "Without authorization from Allison Engineering." Holloway said, "Yes, sir," Spencer said. "And those modified aircraft successfully intercepted and destroyed Yamamoto's formation." Holloway said, "Yes, sir." Spencer was quiet for maybe 10 seconds. Then he said, "How long does the modification take?" Holloway said, 24 minutes per aircraft. Spencer said. How many aircraft can you modify before tomorrow's dawn patrol? Holloway said, all of them. Spencer said, do it. By April 20th, Holloway had modified every P-38 in the 70th Fighter Squadron. 14 aircraft. 8 hours of work. The combat results started immediately. On April 22nd, 6 P-38s from the 70th Squadron intercepted a Japanese reconnaissance flight 90 miles northwest of Guadalcanal. The reconnaissance aircraft was a Mitsubishi Ki-46, the same type that Lieutenant Mitchell had failed to catch on March 3rd. This time the P-38s caught it in 4 minutes. Lieutenant David Harris closed to 200 yards and fired a 2-second burst. The Ki-46 exploded. Harris's after-action report noted, aircraft maintained speed throughout intercept. Engines remained synchronized during extended high-power operation. No performance degradation observed. On April 24th, 8 P-38s engaged a formation of 4 Japanese bombers escorted by 8 Zeros. Normal tactics would have the P-38s make one high-speed pass and then extend away because they couldn't sustain maneuvering against the Zeros. Not anymore. The P-38s stayed in the fight. When Zeros tried to turn, the P-38s could maintain speed through the turns. When Zeros tried to dive away, the P-38s followed without losing ground. The engagement lasted 11 minutes. 3 bombers destroyed. 2 Zeros destroyed. 1 P-38 damaged but returned to base. Captain William Johnson, flight leader, reported, the aircraft performed as advertised for the first time since I've been flying. P-38s. We had power authority throughout the engagement. Word spread to other fighter groups. On April 25th, the commander of the 339th Fighter Squadron requested Holloway's presence. Holloway modified 11 aircraft in one night. By April 30th, Holloway had modified 47 P-38s across 3 squadrons on Guadalcanal. The statistics were undeniable. In March 1943, before the modifications, P-38 squadrons on Guadalcanal had a 0% success rate on intercept missions. 0 successful intercepts out of 14 attempts. In May 1943, after the modifications, the success rate was 73%, 16 successful intercepts out of 22 attempts. The Japanese noticed. Intercepted radio communications from Japanese units showed confusion about American fighter performance. One translated message from May 8 stated, American fighters' speed and climb performance has improved significantly. Recommend increased escort strength. Another message from May 14, P-38. Aircraft are maintaining pursuit through previously effective evasive maneuvers. Previous tactical guidance appears obsolete. The Japanese didn't know what had changed. They didn't know about magneto timing or engine synchronization. They just knew the P-38, which had been a mediocre performer for months, was suddenly dominating. And they couldn't figure out why. On May 18th, an engineering team from Allison Engine Company arrived at Guadalcanal. They were investigating reports of non-standard engine performance characteristics. Was corporate language for someone's been modifying our engines without permission. The team chief was named Robert Patterson. He was 41 years old. He'd been an engineer at Allison for 16 years. He arrived with inspection equipment, technical manuals, and the authority to ground any aircraft not meeting factory specifications. He inspected the first P-38 at 0900 hours on May 19th. He removed the magneto access panel. He saw Holloway's custom timing tag. He checked it with a timing light. He found the 3-degree advancement immediately. He inspected 3 more aircraft. All had the same modification. He asked who had authorized it. The squadron commander said, I did. Patterson said, you don't have that authority. The squadron commander said, then court-martial me. But you're not changing those engines back until I have a written order from General Kenny himself. Patterson inspected the remaining aircraft, 47 P-38s with unauthorized timing modifications. He took detailed notes. He photographed the custom timing tags. He documented everything. Then he ran a full-power ground test on one of the modified engines. He monitored RPM synchronization, vibration levels, and power output. The engine ran perfectly. Both magnetos fired precisely. Synchronization held stable within 10 RPM. Power output was actually 4% higher than factory specification. Patterson ran the test 3 more times, same results. On May 21st, Patterson filed his engineering report. The report stated, "Field modification to magneto timing produces measurable improvement in engine synchronization and power output. Modification appears both safe and effective. Recommend incorporation into standard maintenance procedures." The report never mentioned who had performed the modifications. It never mentioned authorization violations. It never mentioned court-martial potential. The report just said the modification worked. On June 3, 1943, Army Air Force's Technical Order 0116517 was quietly issued to all P-38 maintenance units in the Pacific Theater. The order provided detailed instructions for optimized magneto timing adjustment. The procedure described advancing timing by 3 degrees and installing reference marks. The order never used Holloway's name. It never mentioned Guadalcanal. It never acknowledged that a sergeant had solved a problem that Allison's engineering department hadn't. It just told mechanics to do what Holloway had been doing since April 17th. By August 1943, every P-38 in the Pacific Theater had the modification. By October 1943, it was incorporated into new aircraft on the factory assembly line. The P-38's reputation transformed. In early 1943, it was considered a problem aircraft with unfulfilled potential. By late 1943, it was the premier American air superiority fighter in the Pacific. And it was all because one sergeant decided that saving lives was more important than following rules. The official Army Air Force's history of the South Pacific Campaign mentions Operation Vengeance in exactly 3 paragraphs. Those paragraphs describe the mission's planning, execution, and strategic impact. They mention Captain Lanphier and Lieutenant Barber by name. They credit 18 P-38 pilots with exceptional performance during extended-range interception. They never mention Technical Sergeant Frank Holloway. In June 1943, Allison Engine Company issued Technical Service Bulletin 117, which formally incorporated the magneto timing adjustment into recommended maintenance procedures for all V1710 engines. The bulletin credited field observation and engineering analysis for identifying the improvement. It never mentioned who had performed that field observation. In August 1943, the Army Air Forces issued a commendation to the 339th Fighter Squadron for outstanding maintenance practices resulting in improved aircraft readiness and combat effectiveness. Holloway's name wasn't on the commendation. This wasn't conspiracy or cover-up, it was bureaucratic self-protection. If the Army officially acknowledged that an unauthorized field modification had been critical to the Pacific's most important intercept mission, they'd have to explain why that modification wasn't authorized in the first place. They'd have to admit their own procedures had prevented a solution that saved lives. Easier to just quietly incorporate the fix and never discuss how it was discovered. The pilots knew. Every P-38 pilot in the Pacific Theater knew that something had changed in April 1943. They knew their aircraft suddenly performed the way it was supposed to. They knew someone had fixed a problem that had been killing mission effectiveness for months. But most of them never learned Holloway's name. Captain Thomas Lanphier survived the war. He flew 68 total missions from Guadalcanal and later bases in the Philippines. He was officially credited with 6 confirmed kills. The actual number was probably higher. After the war, he returned to Detroit and worked in his family's insurance business. Lanphier died in 1987 at age 68. He never publicly discussed the unauthorized engine modifications that made Operation Vengeance possible. When asked about the Yamamoto mission, he talked about navigation, tactics, and the skill of his wingmen. He never mentioned the engines. Lieutenant Rex Barber survived the war with 10 confirmed kills. He became a commercial airline pilot after leaving the Army Air Forces and flew for Western Airlines for 27 years. He died in 2001 at age 84. Technical. Sergeant Frank Holloway remained at Guadalcanal until November 1943. He was promoted to Master Sergeant in September 1943 for exceptional technical proficiency and dedication to duty. The promotion citation didn't mention the timing modifications. In November 1943, Holloway was transferred to the Philippines to help establish maintenance operations for newly arrived P-38 squadrons. He spent 19 more months in the Pacific Theater. He returned to Detroit in June 1945. He was 28 years old. He'd been away from home for 3 years. He'd maintained engines through tropical storms, volcanic dust, and Japanese air raids. He'd committed what could have been court-martial offenses to save lives. He never talked about it. He went back to Ford Motor Company. He worked in engine development. He applied lessons learned from maintaining Allison V-1710s to post-war automotive engine design. He retired in 1981 after 44 years at Ford. The lives saved by Holloway's modification are difficult to quantify precisely, but the data provides estimates. Between February and April 1943, before the modification, P-38 squadrons on Guadalcanal flew 14 intercept missions with 0 successful intercepts. Between May and August 1943, after the modification, they flew 47 intercept missions with 34 successful intercepts. That's 34 missions where American pilots achieved tactical objectives they'd been unable to achieve before. Those missions included bomber interceptions, reconnaissance aircraft kills, and convoy attacks. If we conservatively estimate that each failed intercept mission had a 50% probability of resulting in American casualties from unchallenged Japanese attacks, and if we estimate average casualties of 5 personnel per attack, then 14 failed missions represents approximately 35 American lives lost. After the modification, those intercepts succeeded. The missions that would have failed instead accomplished their objectives. The Japanese aircraft that would have attacked American positions were shot down before reaching their targets. That's a conservative estimate of 35 lives saved in the first 4 months alone. By August 1943, every P-38 in the Pacific Theater had the modification. The improved interception success rate continued through the end of the war. If we extend the analysis across 2 years of Pacific Theater operations, involving hundreds of P-38s flying thousands of intercept missions, the lives saved estimate increases to between 80 and 120 American pilots and potentially thousands of American ground personnel who were protected by successful interceptions. One sergeant's decision to violate regulations and trust his own engineering judgment had cascading effects that changed the outcome of hundreds of missions. But the most significant impact wasn't measured in statistics. It was measured in confidence. Before April 1943, P-38 pilots flew with the knowledge that their aircraft would betray them at the worst possible moment. They knew the engines would drift out of sync. They knew the speed would drop. They knew their tactical advantages would disappear when they needed them most. After April 1943, they trusted their aircraft. When they needed speed, it was there. When they needed power, the engines delivered. When they needed to stay in a fight, the airplane didn't quit. That confidence changed how they fought. They took engagements they would have avoided before. They pressed attacks they would have abandoned before. They turned a fighter that had been underperforming into a weapon that dominated. And it started with one sergeant who decided that bureaucratic approval was less important than keeping pilots alive. Frank Holloway lived in suburban Detroit for 63 years after returning from the war. He married in 1947. He had 3 children. He worked at Ford. He maintained a garden. He rarely discussed his military service. When people asked what he did in the war, he'd say he was a mechanic. If they pressed for details, he'd mention Guadalcanal and P-38s and leave it at that. He never mentioned Operation Vengeance. He never mentioned unauthorized modifications. He never mentioned that his decision to violate regulations had enabled the single most strategically important fighter intercept mission of the Pacific War. In 1987, an aviation historian named Michael Clarenbold was researching P-38 operations in the South Pacific. He was reviewing maintenance records from Guadalcanal when he found references to field modifications to magneto timing implemented in April 1943. The records mentioned Technical Sergeant F. Holloway. Clarenbold tracked Holloway down through Ford Motor Company retirement records. He called Holloway's house in October 1987. Holloway was 70 years old. He initially declined to be interviewed. Clarenbold called 3 more times. Finally, Holloway agreed to meet. The interview took place in Holloway's garage. He had a restored 1942 Ford pickup he was working on. While adjusting the pickup's ignition timing, he talked about P-38 engines. He described the synchronization problem. He explained the magneto timing solution. He detailed the April 17th modifications. He talked about watching Lanfear's formation take off and not knowing if they'd come back. Clarenbold asked why he'd risked court-martial. Holloway stopped working on the pickup and looked at him. Men were dying, Holloway said. I knew how to fix it. Everything else was just paperwork. Clarenbold asked if he regretted not receiving official credit. Holloway said, "Credit doesn't matter. Lanfear came back. Barber came back. All 18 of them came back. That's what matters." The interview lasted 3 hours. Clarenbold published his findings in a 1989 article for the American Aviation Historical Society Journal. That article was the first public documentation of Holloway's role in Operation Vengeance. By then, Holloway was 72 years old. He received a few letters from former P-38 pilots thanking him. One letter was from Rex Barber. Barber wrote, "I never knew your name until I read the article. I'm 42 years late saying this, but thank you for getting us home." Holloway kept that letter in his workshop until he died. Thomas Lanfear and Frank Holloway lived in the same city for 42 years after the war. They were both in Detroit. Lanfear was working in insurance. Holloway was working at Ford. They were 11 miles apart. They never met again until 1983, when a local Detroit newspaper did a story on Operation Vengeance's 40th anniversary. The newspaper arranged a meeting between Lanfear and several ground crew members who'd supported the mission. Holloway was one of them. According to witnesses, Lanfear and Holloway shook hands and talked for maybe 10 minutes. The conversation was private. Neither man discussed it publicly. But after that meeting, they exchanged phone calls every April 18th for the next 4 years, until Lanfear's death in 1987. No one knows what they talked about during those calls. But it's easy to imagine 2 men from Detroit. One who flew the mission, one who made the mission possible. Both knowing they'd violated regulations to accomplish something that regulations had prevented. Both knowing they'd saved lives. That's how innovation actually happens in war. Not through official channels or engineering committees or carefully controlled testing programs. Through people who see problems, understand solutions, and refuse to let bureaucracy kill the men they're trying to protect. Not through officers making strategic decisions. Through sergeants making tools work the way they're supposed to work. Through mechanics who trust their hands and their judgment more than they trust paperwork. Through people who understand that rules exist to support the mission, and when rules prevent the mission, the rules need to be ignored. Frank Holloway died in December 2008 at age 91. His funeral was attended by family, Ford coworkers, and 3 former Army Air Forces pilots who flew P-38s in the Pacific. One of them had flown on Operation Vengeance. There's a display at the National Museum of the United States Air Force in Dayton, Ohio. The display covers Operation Vengeance. It includes mission maps, aircraft models, and photographs of Lanfear and Barber. It describes the strategic importance of killing Admiral Yamamoto. In the corner of that display, There's a small photograph of a P-38 engine with the magneto access panel removed. Next to the photograph is a metal timing tag with a scribed reference line. The caption reads, Field Modified Timing Tag, April 1943, Guadalcanal. This unauthorized modification improved engine synchronization and was later adopted fleet-wide. It doesn't mention Holloway's name, but the timing tag is there. A small piece of aluminum with a drilled hole and a reference line. Made by a sergeant who decided that keeping pilots alive was more important than waiting for authorization. 68 pilots flew P-38s from Guadalcanal in 1943. 43 of them survived the war. Many of them lived into their 70s and 80s. They had families. They had careers. They had lives that might not have existed if their engines had kept drifting out of sync every time they needed maximum power. Each one of those lives matters. Each one deserves to be remembered. And each one was protected, at least in part, by a mechanic who trusted his judgment and refused to let bureaucracy kill the people he was trying to save. If you found this story compelling, please like this video and subscribe to our channel. Leave a comment telling us where you're watching from and whether you've heard of Operation Vengeance before. These stories matter because they remind us that history isn't just made by generals and admirals. It's made by sergeants and mechanics who see problems, find solutions, and don't wait for permission to save lives. Thank you for keeping these stories alive.